Hi, let's now continue on our examples of limits of trigonometric functions. So here we have the limit of sine squared z over z as z approaches 0. We can rewrite this expression as the limit of sine squared z is simply equal to sine z multiplied by sine z. So sine z multiplied by sine z times sine z is equal to sine squared z all over z as z approaches 0. Now we can divide this into two functions. Let me just illustrate here. So we have one function here and then another function here. So we can therefore express this as the limit of sine of z over z as z approaches 0 multiplied by the limit of sine z as z approaches 0. So therefore this is simply equal to, again, limit of sine z over z as z approaches 0 is equal to 1 multiplied by limit of sine z as z approaches 0 is equal to 0. So the answer therefore is equal to 0. So for our next problem, we have the limit of sine of 7z multiplied by cosine of 4z over z as z approaches 0. So we can rewrite this into the limit of sine of 7z over z multiplied by the cosine of 4z as z approaches 0. Now, if I have 7z here, and then let me just clean it up a bit. So if I have 7z here, and I put 7 here, okay, in the denominator, so that it will be cancelled out, it will be 7 over 7, meaning equal to 1, I can multiply the numerator by 7. So I put 7 here, I need to put a 7 on the numerator, so that 7 divided by 7 is equal to 1. So you're not changing the expression. So now, limit of sine z over sine of 7z over 7z multiplied by cosine for 7z times 7. So what we can do, we can split this. We can actually, by the way, move this 7 outside. This is equal to 7 multiplied by the limit of sine of 7z over 7z as z approaches 0 multiplied by the limit of cosine of 4z as z approaches 0. Okay, let me just take some space, remove some of this to have some space. Now, take note, let seven z let 7z equal to, let's say, x. So therefore, as z approaches 0, we can say that x approaches 0. So let's rewrite now this whole thing here as is equal to 7. The limit of sine 7z, let's replace 7z by x. Sine of x over 7z here is again replaced by x over x. And as z approaches 0, x approaches 0. As x approaches 0. Multiplied by the limit of a cosine of 4z as z approaches 0. Now remember or recall that limit of sine x over x as x approaches 0 is equal to 1. So now we have 7 here. This is now equal to let me just put the equal sign. This is equal to 7 multiplied by the limit of sine limit of sine x over x as x approaches 0. This is 1 multiplied by the limit of cosine 4z as z approaches 0. So if z is substituted by 0, 4 times 0 is 0. So cosine of 0 is equal to 1. So 7 times 1 times 1, this will give you 7. So our final answer will be 7. By the way, before we proceed any further, please don't forget to subscribe to our channel. Press the subscribe button so that you'll have the full series of the calculus made easy. Now for our next problem, the limit of cosine of 1 minus cosine of z over z squared as z approaches 0. So limit of 1 minus cosine z over z squared. So what we can do, let's see, let me see. What if I will express it like this? Okay, multiplied by 1 over z. If you recall, we have an expression limit of 1 minus cosine z over z is equal to 0. So this is the same. 1 minus cosine z times 1 is 1 minus cosine z. Z times z is equal to z squared. Now, if I substitute this, I get the limit of this and the limit of this. You will get, again, by the limit of the product of two functions is equal to the limit of, or the product of the limit of two functions. I can rewrite this as the limit of 1 minus cosine of z over z as z approaches 0 multiplied by the limit of 1 over z as z approaches 0. But if you solve this now, limit of 1 minus cosine z over z is equal to 0. And limit of 1 over z as z approaches 0 is basically infinity. So 0 minus infinity, this is indeterminate. So that means I cannot use this. We have to find another way to express this so that I won't get an indeterminate answer. In this case, it's 0 times infinity. So what can we do in this case? So limit of 1 minus cosine z over z squared, let me write it again. Limit of 1 minus cosine of z over z squared as z approaches 0. Let's try multiplying the numerator by its conjugate. So in this case, let's multiply this by 1 plus cosine of z. Now, if we multiply this by the conjugate, 1 plus cosine z, we have to do the same thing in the denominator. We also need to put 1 plus cosine of z. Why? 1 plus cosine of z divided by 1 plus cosine z is equal to 1. So basically, 1 over 1, which is 1, multiplied by this expression is still equal to the original expression of 1 minus cosine z over z squared. So now, 1 minus cosine z multiplied by 1 plus cosine z. If you recall, a squared minus b squared, the difference of two squares, is equal to the product of two binomials a plus b, a minus b. So in this case, we can say that a is equal to 1 and b is equal to cosine z. So a plus b is 1 minus cosine, sorry, a minus b is 1 minus cosine z, and a plus b is equal to 1 plus cosine z. So a squared minus b squared will simply be 1 squared minus cosine z squared. So therefore now we can express this product of two binomials as difference of two squares. In this case, I take the square of 1, which is 1 squared is equal to 1 basically, minus cosine z is equal to cosine z squared, which is, let's write it as cosine squared z, all over z squared multiplied by 1 plus cosine of z as z approaches 0. Now recall that sine of squared z plus cosine of squared z is equal to 1. This is from the trigonometric identity, from our basic trigonometry. Sine squared z plus cosine squared z is equal to 1. Therefore, 1 minus cosine squared z is equal to sine squared z. So we can write it therefore that sine squared z is equal to, from this trigonometric identity, sine squared z is equal to 1 minus cosine squared z. So let's clean this up a bit. So now what we can do, let's rewrite this function. We can rewrite it as the limit of 1 minus cosine squared z is equal to sine squared z, sine squared z over z squared multiplied by 1 plus cosine of z as z approaches 0. So here we have sine squared z over z squared and then 1 plus cosine z. We can express this in a different way. Again, let me just get some space so it to be clearer. Now, we can write this as a product of two functions. One is sine squared z over z squared. The other is 1 over 1 plus cosine z. So we can write this as the limit of sine z, okay, over z squared as z approaches 0, okay, multiplied by, the limit, okay, 1 over 1 plus cosine of z as z approaches 0. If you recall, sine squared z over z squared is simply equal to sine z over z squared. Okay, the sine squared z over z squared is this one, is sine z over z squared. Multiply now by this function 1 over 1 plus cosine of z. Now, again, this can be rewritten as, I can put the limit inside this. Again, this is coming from our limit laws. If you've kind of forgot about it, I suggest you go back to our videos concerning limit laws. So I can express this as the limit of sine of z over z as z approaches 0 squared multiplied by the limit of 1 over 1 plus cosine of z as z approaches 0. So recall, limit of sine z over z as z approaches 0, this is simply equal to 1 squared. You'll have 1 squared multiplied by limit of 1 over 1 plus cosine z as z approaches 0. This is equal to 1 divided by 1 plus cosine of 0 is equal to 1. So you have 1 multiplied by 1 plus 1, 2. 1 times 1/2. So the answer, the final answer for this problem is 1/2. Okay, that's all for this video. We'll have more examples in the next video. See you there.